complete. Representation of a complex number in two different forms. One is called modulus argument form. Which is also known as polar form. Another method is exponential form. Okay. Now, my one question to you is, suppose I say modulus of a complex number is 3. Argument of the complex number, argument or amplitude, both are same, is let's say pi by 3. Plot it on a Argand's diagram. How will I plot it on an Argand's diagram? What I'll do is, I'll draw the x-axis and y-axis. That's a real axis and imaginary axis. Then I will take this line, one line, and rotate it through an angle 60 degrees. Imagine I rotate it through an angle 60 degrees. What will I get? I'll get a line like this. So this is making angle 60. Then on this line, I'll cut a length of 3 units. 1, 2, 3. And this point is your Z. This point is your Z. And we call it as 3, 60 degrees. And we call this coordinate as polar coordinate. So polar coordinate also has got 2 numbers. First number is distance from the origin to the point, and second number is the angle of rotation. Rotation from the x-axis. That is what we are. Or is it clear to you?
Yes.
Yes, sir.
Yes, sir.
Now, what I'm going to do is, what is polar form? Suppose this complex number has modulus R and angle theta. And this complex number is also A plus BI. Then this is A and this is B. So I can say cos theta is equal to adjacent side upon hypotenuse. Sin theta is equal to opposite side upon hypotenuse. So A is equal to R cos theta and B is equal to R sin theta. So the polar form, I can write it as, the polar form is what? In place of A plus BI, A will be replaced by R cos theta and B will be replaced by R sin theta. If you take R common, this format of writing a complex number is called a polar form. R is a modulus, theta is the argument. So what is the polar form of this complex number? The polar form of this complex will be R is 3 cos pi by 3 plus I sin pi by 3. It is not necessary that you should write the angle in radian itself. You can write the angle in degree also, no problem. That is up to you. Is it clear to you?
Yes, sir.
Yes,
So,
sir.
so they will ask you, write the complex number -1 plus root 3i in polar form. The first thing that you have to do is calculate the modulus. What is the modulus? Root of a square plus b square.
So it's
You
2.
get 3 plus 1, 2. Next is calculate the argument. Argument is, which quadrant is -1 plus
Second
3? Second quadrant. Second quadrant is pi plus tan inverse b by a. That is pi plus tan inverse b is root 3 and a is -1. The minus comes outside. So minus pi by 3 because 60 degrees.
Yes, sir.
So your answer became 2 pi by 3.
2 pi by 3.
So the polar form of the complex number r into cos theta plus I sin theta. Replace r as 2 cos 2 pi by 3 plus I sin 2 pi by 3. If you put the values, you'll come back to the question. Cos 2 pi by 3's value and sin 2 pi by 3's value, if you put here, you will come back to minus 1 plus root 3i. So don't do that. You have to leave it over here only.
Okay.
Have you understood?
Yes,
Now
sir.
I'm going to teach you what is exponential.
Yes.
What is exponential form? Now, a little bit bugging is required because unless I teach you further in mathematics, I cannot explain how it came. Whenever I come across cos theta plus I sin theta, there is a notation for it, e raised to I theta. I'm going to call it notation. Actually, it is not notation. I can prove that e raised to I theta, but not now after calculus is taught to you. So if I write cos pi by 3 plus I sin pi by 3, it is nothing but e raised to I pi by 3. If I write I raised to pi by 2, e raised to I pi by 2, not I raised to, e raised to I pi by 2. It means cos pi by 2 plus I sin pi by 2. That is 0 plus I. If I write e raised to I pi, it means cos pi plus I sin pi. It means minus 1 plus I into 0, which is minus 1. Did you understand the meaning of this notation?
Yes, sir.
So at
Yes,
present,
sir.
think as a notation.
Yes, sir.
After teaching calculus next year, I'll tell you how this became e raised to I theta became cos theta plus I sin theta. At present, you take it as a notation. Whenever I write e raised to I alpha, it means cos alpha plus I sin alpha.
I
Just think
sin
that this
alpha.
is a notation for this, but actually it is not notation. There's a real proof for it.
So we have to just remember it now.
Yeah, you have to just remember it. Cos alpha plus I sin alpha is e raised to I alpha. Like that you have to remember. So the exponential form for this problem would be 2 into e raised to I 2 pi by 3. This is known as exponential form. And this is known as polar form. And this is known as Cartesian form. This is like a coordinate, minus 1 root 3. So we call it Cartesian form of the complex number. If you write like this, it is called polar form. If you write like this, it's called exponential form. Is it clear to everybody? Yes or no?
Yes, sir.
Yes, sir.
Now I am going to ask you a question. Let me see how you'll answer. Okay, very simple question. I have a complex number 2 e raised to I 40 degrees. Another complex number 3 e raised to I 50 degrees. What is Z1 into Z2? What is Z1 divided by Z2? And then you have to tell me what is modulus of Z1 into Z2? What is modulus of Z1 divided by Z2? What is argument of Z1 into Z2? And what is argument of Z1 divided by 2? Remember, when I multiply two complex number, I get a new complex number. That new complex number's modulus is how much? When you divide two complex number, I get a new complex number. What is the modulus of that new complex number? Same way the arguments. By writing in this manner, this calculations becomes just mental calculation. Look at this. Z1 into Z2 means 2i raised to 40 degrees into 3i raised to 50 degrees. This became 2 into 3, 6.
Yes, sir.
Powers a raised to m into a raised to n is a raised to n.
A raised to m plus n.
So they were powers will get added.
90.
E raised to
90.
90. So modulus of the product is 6 and the argument of the product is 90.
90.
6 and the argument of this is 90 degrees. Have you got it?
Yes.
Yes,
sir.
sir.
Same way division if I do, it becomes 2 by 2 e raised to I 40 degrees
Hmm.
divided by 3 e raised to I 50 degrees. That is 2 by 3 e raised to
E raised to
minus
minus
I 10
10.
degrees.
10 degrees. Yes, sir.
Okay. Now, if you are talking about modulus, it will be 2 by 3. This part is
So,
modulus.
so one
What?
question, this minus I, the minus should come inside the bracket instead of coming on I.
Okay, no problem. That is up to you to write it.
It will be the same only, na, if you do that.
Yes, 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 yes.
Okay.
So the argument is minus 10 degrees. But in our 11th standard form, we don't use minus 10. Instead of minus 10, what will you say? Instead of minus 10, what do you say? This way we measure, which
Oh,
is 350 degrees. That is up to you. This is also
360
correct. This is
minus
also correct.
10.
If you don't want to use negative angle, from 360, you subtract that. Okay. So that is up to you. If you want the argument to lie between minus 180 and plus 180, subtract it from 360 or add 360 to it. Otherwise, you leave it as minus 10. If you do anyhow, I'll give you full marks. Even if you write minus 10 also, I'll give you full marks. Even if you write 350 also, I'll give you full marks. Both are correct.
Okay.
Is it clear to everybody?
Yes, sir.
Yes,
Yes,
sir.
sir.
What is the benefit
sir.
of writing in exponential form? Just imagine, if I want to calculate this in the other method, I have to use all tan inverse b by a formula, then I have to calculate it. But here I can do it very fast. Modulus very simple. Argument amplitude also very simple, just by simplifying this. So that is the benefit. Clear? Can we write down? Can we
Yes,
write down?
sir.
Yes,
Yes.
sir.
Okay,
Yes.
write down. If Z is A plus BI, this is known as Cartesian form. Modulus of Z, I am denoting by R, is root of A square plus B square. Then theta is argument of Z. For time being, I'm writing tan inverse B by A, but depends on the quadrant. Use the formula. Okay, I just wrote tan inverse A. Then polar form of the complex number Z is R into cos theta plus I sin theta. And exponential form of Z is equal to R e raised to I theta. So much is clear?
Yes, sir.
Yes, sir.
1 second.
Yes.
Yeah. This is all you have to remember. How to calculate R, how to calculate theta, how to express in polar form, how to express in exponential form.
Done, sir.
Done? Okay,
Yes.
then we start with the
Sir,
problem.
1 minute. Sir,
Yes.
1 minute.
Take your time. Take your time.
Yes, sir, done.
Done? Okay. Express the following complex number. In polar form and exponential form. First question, -1 plus root 3i. Second question, minus I. Third question, -1. Fourth question, 1 upon 1 plus I. Fifth question, 1 plus 2I upon 1 minus 3I. Sixth question, 1 plus 7I divided by 2 minus I the whole square. Z is minus 1 plus root 3I. Okay, now calculate the modulus. What is the notation for modulus? R.
R.
Root of A square plus B square. Initially, we'll write all the formula. Later on, we'll not write all this formula. Root 10 is fine. Now we have to calculate the argument. If you see argument or amplitude, both are same. This is in which quadrant? Second quadrant. So pi plus tan inverse B by U.
Root.
No problem?
Sir,
It will be 2.
It will be 2, sir. Answer will be
2, sir. Answer 2
root
Minus
4.
1 plus root 3 है ना?
Yes,
Yes, sir. तो उसका
X
स्क्वायर होगा
coordinate
तो
is
3
minus 1
आएगा.
है. Y coordinate root 3 है. तो कहाँ पे आएगा? बराबर है ना?
No, sir, I am talking about modulus.
Modulus.
It should be, answer should be 2.
I'm sorry. I squared 3 and
Okay,
root
sir.
9 plus 1, 10 I wrote. I'm really sorry.
It's okay, sir.
Tan inverse B by A. B is root 3 upon minus 1. 5 minus tan inverse root 3. 5 minus pi by 3. 2 pi by 3.
2 pi by 3, sir.
So now we'll write polar form. What is the formula for polar form?
R.
R.
Theta plus
Cos theta plus
I sin
I sin theta.
R is 2. Theta is 2 pi by 3 plus I sin 2 pi by 3. Try to write angle in a radian as far as possible. But if you're feeling difficult to write in radian, you can write in degree also. Then exponential form. Formula for exponential form, R e raised to I theta. 2 e raised to I 2 pi by 3. And that's answer. I hope you understood properly.
Yes, sir.
Yes, sir.
Yes,
Try to write yourself next problem.
sure. Wait one.
Fine. Can we go to next? Are you
Yes.
ready?
Yes, sir.
Next is minus I. Minus I means कहाँ पे आएगा?
Fourth quadrant, sir.
Not fourth quadrant, on axis.
Negative y-axis.
Negative y-axis. बराबर है ना?
Yes, sir.
ऐसा आएगा ना? So we can just directly write the modulus.
Yes, sir. This is 1.
A is 0. Okay. 0 minus I.
Should be 1.
So it's 1, sir.
It's 1.
1 only. Then
And
And
argument of Z, you have to look at it and don't use any formula.
270 degree.
A rotate करने के लिए कितना आएगा?
270.
270.
270 degrees. That is 3 times 90 degrees. 3 pi by 2 radians. So Z is in polar form. R into cos 3 pi by 2 plus I sin 3 pi by 2. So you don't have to write this one. Directly cos 3 pi by 2 plus I sin 3. And exponential form, r e raised to I theta, r is 1, e raised to I 3 pi by 2. Very simple now.
Yes, sir.
Now third question is minus 1. Can you write minus 1 directly?
Yeah.
Mhm.
Minus 1 idhar aayega.
It will be the negative x
On the axis.
So modulus of z is 1.
1 and the argument is 180 degrees.
Argument
Yeah.
is 180 degrees.
180.
Therefore,
So
form will be
polar form will be
cos pi
cos pi
plus sin pi I.
I sin pi. And r e raised to I pi.
So I pi.
Done. So.
Okay. So whenever it falls on axis, don't use any formula.
Yeah. You can mentally do it.
Mentally do it. Now 1 upon 1 plus I.
Formula.
Okay. I'm going to teach you two methods. Two methods I'm going to teach you. First method, or the easiest method. Do you agree with this? I multiplied by the conjugate.
Yes, sir.
It's down, yeah.
Anybody doubt on this two?
No.
A square minus b square. A square minus b square. I square is minus 1. So you can. Now modulus of z. Root of
1 upon
a
4
square plus b square. 1 by 4 plus 1 by 4.
1 by 2.
Root of 2 by 4. 1 by root 2. Argument of z. What's the quadrant में आएगा?
It will be in the
X is positive, y is negative. Fourth quadrant, na?
Fourth, yeah, fourth quadrant. Fourth
That is 2 pi plus tan inverse p by a.
360. Yeah.
That is 2 pi plus tan inverse minus half upon half. 2 pi minus tan inverse of 1. 2 pi minus pi by 4. 7 pi by 4. So now I can write
Polar.
form. R into
1 by root 2.
1 by root 2.
7 pi by 4.
7 pi by 4
I
plus I sine 7 pi by 4.
and exponential form
1 upon root 2. 1 by root
1
2.
upon root 2 I 7 pi by 4.
1 upon 2 e raised to I.
E raised to
I sin pi.
Now next method I'm going to teach you in a little different way, but this is a method you should follow in the exam, but just for a joke. Are you ready?
Yes, sir.
1 minute.
Yeah.
Yes, sir.
Yes, sir.
In the exam we follow the safe method, but just for interest I'm going to show you another method.
Yes, sir, done.
Done? Okay. See my another idea. 1 is nothing but, where is 1 on the axis here? Na? So modulus is 1, angle is 0. So r e raised to I theta. R is 1, e raised to I 0. You can read it 0, no? So e raised to I0 is 1 is nothing but e raised to I0. 1 plus I is nothing but root 2 into e raised to I pi by 4. Do you agree? Don't agree? What is modulus here? 1 square plus 1 square root, that become root 2.
Root 2, sir.
Yes.
And theta is tan inverse b by a, tan inverse 1 pi by 4. So 1 upon 1 plus I would be e raised to I0 upon root 2 into e raised to I pi by 4. That became 1 by root 2 into e raised to, powers are subtracted. So I into 0 minus pi by 4. So 1 by root 2 into e raised to minus I pi by 4. And e raised to minus pi by 4 means this angle.
7
But that is 360 minus pi by 4.
5.
That is for you to write. 2 pi minus pi by 4. That is 1 by root 2 e raised to I 7 pi by 4. This you can do mentally like this. Same answer you got. Same answer you got. Did you understand? What did I do? Wrote this in exponential form. Wrote this in exponential form. Simplified and wrote the answer. Have you understood this method?
Yes, sir.
Some place this method will be better. Some place the first method will be better. Okay. So it's not necessary
Yes.
for you to write this. We'll write it in some other question. Okay. Let's say next problem. Let's do this. In this problem, we'll use only first method, conjugate method, because we don't have perfect theta for both of them. So calculation of theta would be difficult if you do my second method. So do by this method only. Which one?
This one.
Conjugate.
Conjugate, yeah.
method. Please write down question. 1 plus 2i upon 1 minus 3i. Multiply by the conjugate. On expanding 1, 2i plus 3i minus 6. Three plus 2. Minus 5 plus 5i. Divided by 9 plus 1.
10, sir.
Separate it. Minus 1 by 2 plus half I. Calculate the modulus.
So the modulus is again going to be 1 by root 2 now.
Correct. Then calculate the argument. Second quadrant.
-1. I minus.
So we have to write in both the format, no?
This one.
R is 1 by root 2. So cos 3 pi by 4. Plus sine 3 pi by 4. Then exponential form.
1 by root 2
R
E
e raised to I theta. 1 by root 2 e raised to I 3 pi by 4.
3 pi by 4.
Last question you are doing yourself. I'm going to pause the video for a minute. Everybody completed this?
1 second, sir.
Yes, sir.
Take your time. So 1 plus 7i into 3 plus 4i upon 3 minus 4i into 3 plus 4i. When you open this, look at this. Real part you take first, 3. Imaginary part is real part. This also gives you real part, 7i and 4i. That gives you 28i square, so minus 28. Then how do you get I? When 1 multiply with 4i, 7i multiply with 3, 21. So this is 3 square minus 4i the whole square. That gives you minus 25 plus 25i divided by 25, which will give you minus 1 plus I. That is your z. So modulus of z is root of minus 1 square plus 1 square.
1, sir.
Root 2.
Correct now? Root 2, no?
Yes, sir. Acha, haan. Root
Argument
plus
of z is second quadrant. So pi plus tan inverse b by a. That is pi plus tan inverse of minus 1. Pi minus pi by 4.
pi by 4.
So 3 pi by 4. So you can write polar form z r into cos theta plus I sin theta. R is root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Then you have to write exponential form. R e raised to I theta root 2 e raised to I 3 pi by 4.
Polar form, no?
Given to us in polar form, and we have to write an x plus I. That means we have to make it into Cartesian form. Instead of writing this way, you can say Cartesian form.
Okay, so you have to
Just put the value of this 2, you get the answer. That is root 3 into cos, how much it is? Pi by 6, 180 by 6, that is 13.
30 degree.
And
30
cos
degree,
30's value is how much?
half.
3 by 2.
Root 3 by 2.
But sorry, root 3 by 2.
Sin
Sorry.
30 is half.
Half.
So just put the value here. Root 3 by 2 plus I into 1 by 2. Now open the bracket. 3 by 2 plus
3 by 2.
root 3 by 2 I.
I.
It. Answer is over. So I don't think it's a difficult task. Just put the value of the trigonometric ratio. The polar form will convert it to Cartesian form. That's why I told you when I was doing Cartesian form, do not put the value back. If you put the value back, you'll change to Cartesian.
You'll get the question.
Yeah, because
only.
both are same stuff only. No, only
Yes.
we are writing in different way.
It's substituting kind of.
Yeah, we are writing in two different format. One in angle and modulus, another in numbers.
Yeah.
Let's do one more problem of that kind. Root 2 times cos 7 pi by 4 plus I 7 pi by 4. Now only stuff is trigonometry you should know. If you don't know trigonometry, this calculation will be a problem. Cos 7 pi by 4. How to calculate this?
Cos 45 degree.
8 pi minus pi you must write. If you want to make it into radian and do the problem, make a multiple of 4 come over here. So multiple of 4 is 8. Now separate it.
2 pi minus pi by.
Now cos 180 minus theta is minus cos theta.
So it should be 2 pi minus pi by 4.
Yeah, 2 pi. Yes, you are right there. So in that case, 2 pi get deleted. 360 degree get deleted. So cos pi by 4. So 1 by root 2. Same way 7 sine 7 pi by 4 you'll have to calculate. You can use the same method. Sine 2 pi minus pi by 4. Now 2 pi gets cancelled. Sine of minus theta is minus sine theta. So minus 1 by root 2. So your answer root 2 into 1 by root 2 plus I into minus 1 by root 2. So your answer became 1 minus I. Clear?
Yes.
Yes, sir.
So now I'm pausing. I want you to do your. So use the same method. 6 multiple is 6 only.
6 pi minus
So
pi.
5 pi should be written as 6 pi minus pi. Cos of 6 pi minus pi. That is cos of pi minus pi by 6. In second quadrant, cos is negative, so minus cos pi by 6.
Hmm.
Then you have to calculate sine 5 pi by 6. Sine 6 pi minus pi upon 6. Sine pi minus pi by 6. In second quadrant, sine is positive, so sine pi by 6. So half.
Half. Hmm.
7 into minus root 3 by 2 minus I into 1 by 2. So if you want, you can open the bracket. So minus 7 root 3 by 2 minus 7 by 2I.
So it's plus half.
Yeah, because second quadrant, cos sine is
Yes.
positive. Is it fine?
Yes, sir.
Can I move to next one?
Yes, sir.
Yes, sir.
E raised to pi by 3I. Make it into Cartesian form. What is the meaning of e raised to pi by 3I?
Cos
Plus I sine pi by 3. So cos 60 half, sine 60 root 3 by 2. That's the answer. Now do two problems yourself. So cos of minus theta is cos theta, sine of minus theta is minus sine theta. Now you can write this as cos of 3
Pi
pi
plus pi by 3.
I hope all of you got this idea, no?
Yes, sir.
It has been brought there. Now separate it.
Cos pi plus pi by 3.
Yeah.
Minus I.
So cos 180 plus theta goes in third quadrant, so negative. And sine also negative.
Minus.
So 2 negative make it positive. So that became cos of 60 degrees.
Minus half.
And
Plus.
minus half. And this becomes root 3 by 2. That is the question answer for one. E raised to minus 4 by 3 pi I.
The same thing.
Now we'll do the last question. E raised to 5 pi by 6i. Cos 5 pi by 6 plus I sine 5 pi by 6. That is cos 6 pi minus pi upon 6 plus I sine 6 pi minus pi upon 6. That is cos pi minus pi by 6 plus I sine pi minus pi by 6.
So here it will be cos pi by 6 minus I sine pi by 6.
But this in second quadrant, no? So minus.
Minus.
This will be plus.
How come this is in second quadrant? This one should be in fourth
Pi
quadrant.
minus
right?
pi by 6, no? From pi you remove 180 minus an angle. 180
Okay.
से कम तो second quadrant आएगा ना.
अच्छा, हाँ.
So that became
Minus
cos 30. So
minus
minus
2
root
3 by 2.
by 2 plus I sine 30. That is half.
Half.
I hope you understood how to convert into polar form to Cartesian,
Yes, sir.
Cartesian to polar.
Yes, sir.
Yes, sir.
Yes, sir.
Now I need to teach you a small stuff. 2-3 questions I'm going to give you this time, little difficult one. You will yourself try and let me know. Okay. All of you completed?
Yes, sir.
Yes, sir.
And there is
So, 1
something known
minute.
as
thousands of years ago.
when I take a complex number, let's say z, to the power z is r e raised to I theta. What will be z power n? Naturally, r e raised to I theta to the power n.
To the power n, yeah.
That became r to the power n and e raised to I n theta. Now let's compare. If I'm writing this as r cos theta plus I sin theta to the power n. This one is nothing but r raised to n. When I write this in cos theta plus I sin theta form, cos n theta plus I sin n theta. Very interesting. R raised to n and r raised to n gets cancelled. What did I show you? Cos theta plus I sin theta to the power n is nothing but cos n theta plus I sin n theta. For example, cos pi by 3 plus I sin pi by 3 to the power, put a power and tell me, let's say power 4. I can directly write this 4 inside this bracket. So cos 4 pi by 3 plus I sin 4 pi by 3. Did you understand the meaning of this?
Yes.
If you have a power n for cos theta plus I sin theta, that power n will become n theta. So tell me, what is cos theta plus I sin theta raised to 3? How can you write this as?
Cos
Cos 3 theta plus I sin 3 theta.
It is cos 3 theta plus I sin 3 theta. Did you understand this idea? Whatever the
Yes, sir.
power here will get multiplied with the 3. Suppose I have cos theta plus I sin theta raised to half. It is not only for natural number, for any angle you can apply. So this you can write cos theta by 2 plus I sin theta by 2. Did you follow that?
Yes, sir.
Yeah, this is what is known as de Moivre's theorem. MOIVRE theorem. What is de Moivre? Just give the heading. De Moivre's theorem. MOIVRE. So what does de Moivre's theorem says? De Moivre's theorem says cos theta plus I sin theta raised to n. Cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. N belongs to any real number. All real numbers, this De Moivre's theorem is applicable. Proof is very simple. E raised to I theta, the whole raised to n, is e raised to I n theta, which is cos n theta plus I sin. That's it. So cos theta plus I sin theta raised to n can be written as e raised to I theta raised to n, became n theta, now distributed back to polar form. So cos n theta plus I sin. Followed so much?
Yes, sir.
Yes.
And we will stop this with today.
Okay.
I'll
sir.
send you